In this lesson, we're going to learn how to simplify radicals containing variables in the radicand. So for example, during this lesson, you're going to learn how to simplify this radical expression. So where we have the square root of 4, a to the 22nd power, b to the 12th power. So at some point in this lesson, you're going to learn how to do this, and you'll be able to do this. But let's review a couple of things first, and also let's talk about a couple of new ideas that we need to discuss. So we all know that the square root of 16 is 4. And the reason is because 4 times 4 is 16, right? So the square root of 16 is 4. So I need to find two numbers. I need to find a number multiplied by itself that will give you that radicand. And we also know, for example, that the square root of 9 is also 3, because 3 times 3 is equal to 9. Now what I want to do is I want to rewrite 16 as 4 to the second power. So based on just what we just saw, I know that the square root of 4 squared is just 4. So it's just this space right here, right? Okay. And then if I have the square root of 9, that's 3 squared, right? And the square root of 3 squared, we know is the square root of 9, which is just 3. So it's this right here. Y'all agree? Okay. Now the question is this true all the time? If I'm taking the square root of some base raised to the second power, is it always going to be the base? So that's the idea. So that's the part that we need to make sure we understand. So for example, if I have the square root of x squared, just based on what we just said, I know that the square root of x squared is x, right? Because x times x is what? X squared. So when you multiply like bases, you add exponents, right? But is that always true? If I have some base raised to the second power, is it always going to equal the base? All right, well, we know it's true here, right? So the square root of 4 to the second power is 4. It's just that base because 4 squared is 16 and the square root of 16 is 4. But what about this? What about if I had this negative 4 squared? Is it negative 4? Is the square root of negative 4 squared equal to negative 4? No, it's not. Because let's think about that. The square root of negative 4 squared is the square root of, remember, you always do the radicand, you always simplify the radicand first. Negative 4 squared is 16, and the square root of 16 is 4. So the square root of negative 4 squared is 4. And so what we got to do now is I have a negative 4, so I got to take the absolute value of that. So that's where we start talking about the absolute value here. So whenever I'm taking the square root of some base, and again, we're just talking about raised to the second power. Raised to the second power, there are times when I will need the absolute value, and times when I won't. And the times that I need it will be based on what my base is. If it's negative, I need to take the absolute value. If it's not negative, then it's just a base. So when we come back over here, see this right here? I need to be careful with this. I need to be careful when I say that the square root of x squared is equal to x, because that's not always true. That is not always true. For example, if x is, let's say, 3, we have the square root of 3 squared, which is a square root of 9, which is 3, right? So if x is 3, so if I substitute 3 in for x, I get 3 squared. This is what this is, which is a square root of 9, I'm sorry. Square root of 9, which is 3. And that's the same thing as x, isn't it? All right, so that's a true statement here. So if x is 3, then the square root of 3 squared is just 3. Okay? If x is 5, we have the square root, so I'm substituting 5 for x, so I get 5 squared, which is, I'm saying is x. So is that 5? Yes, it is. The square root of 5 squared is the square root of 25, which is 5. Okay, so it looks like the square root of x squared is x, right? It kind of, based on what we just did, it looks like that, but it's not. It is not always x. For example, let's look at x equal -3, and we looked at it. We looked at a sample of it right here where we had -4. So if x equals -3, here's what I have. I have this. So in place of x, I'm going to substitute -3, so I get the square root of -3 squared, right? Which is the square root of 9, which is 3, not -3. Okay? So if I say the square root of x squared equal x, so in this case the square root of -3 squared equals -3, I know the answer is a +3, so I've got to take the absolute value. And that's what we had here. So what we need to look at here is this. We have to make sure that, and notice the absolute value -3 is 3. So we have to make sure that the square root of x squared simplifies to a positive, or let me write it this way, to a non-negative, because it can be 0, x can be 0, so a non-negative real number. So non-negative means positive or 0. Okay, so we have this. Let me go ahead and write it here. So we have this then. So we have this. So we have the square root of x squared, since I have to make sure that it simplifies to a positive or a 0, to a positive or 0, so in other words, a non-negative real number, I have to make sure I say the absolute value of x, because if x is negative, then remember the answer is positive, right? The answer is positive. So if x is negative, I have -3 squared, which is 3, not -3. All right, so right here, when I say the square root of x squared equal x, I got to put this in absolute value to make sure that it's going to be positive, because if I don't put an absolute value like I did here, I'm saying it's negative. And the absolute and the square root of any negative number squared is always going to be positive. Okay, so we have to use absolute value. Now, so if I look at this, the square root of -8 squared, do y'all agree that's going to be the absolute value of -8, right? Which is just what? 8. We know that's true because the square root of -8 squared is the square root of 64, which is 8. So we knew it had to be 8, so that's why I have to take the absolute value of -8. So if I have the square root of 7y squared, then that's going to be the absolute value of 7y. So it's whatever that base is. So the square root of some base raised to the second power is that base. Now I got to put that in absolute value bars because I don't know whether y is positive or negative. So I got to guarantee that it's non-negative number. It's either positive or 0 by putting in an absolute value bar. Okay. So for many students, this gets a little confusing because there are times when you will need absolute value bars, and there are times when you won't. And so for our lesson, though, and for the lessons that we're going to look at in the next few, we will assume that all variables, represent non-negative real numbers. So in other words, I don't have to worry about absolute value bars. So from this point forward, we're going to forget about the absolute value bars, okay? But I just wanted to bring that up because in future courses, you will come back to this idea about when you take the square root of some base raised to an even power, but we're just looking at squared here. There are times when you will have to utilize absolute value bars and times when you won't. But from this point forward, you will always see in the directions that assume that all variables represent, and it may say non-negative real numbers or it may say positive numbers. But in other words, the variables are not going to represent negative numbers. Okay? So you're not going to need absolute value bars. Okay, so here's the idea now. All right, so listen carefully. If I have the square root of, if I want to simplify the square root of x to the 8th, let's think about that, what that is. The square root of x to the 8th is equal to what? Well, whatever this is right here, whatever this is multiplied by itself, it better be x to the 8th, right? So what expression multiplied by itself is x to the 8th? X to the 4th, right? Because when you multiply like bases, you add exponents. 4 plus 4 is what? 8. So the answer is x to the 4th. Okay? We don't have to worry about absolute value bars. Forget about that. We're assuming that all the variables represent either positive numbers or 0. All right. Now, in a future course, you're going to realize here that absolute value bars are not necessary anyway because any number raised to an even power will never be negative. Okay? So that's why in a future course, you're going to see that sometimes I need absolute value bars, sometimes I don't. And from this point forward, we're not going to worry about absolute value bars at all. We're just going to assume that all variables represent non-negative real numbers. Okay, so what about this though? What about the square root of 9x squared? What do you think that's equal to if I simplify this? If I simplify, what do you think that equals to? So basically, what expression times itself is 9x squared? Well, what number times itself is 9? Well, 3, right? And then what times itself is x squared? X times x. So there you go. 3x times 3x is 9x squared. So the answer is 3x. Okay? So it's really not that bad. So let's look at this one. So let's call this number 1, this number 2. And it helps if you think about this right here. It does help. Think about this to get the answer. So number 3, let's go ahead and simplify. Let's say we had the square root of 16x to the 4th. Okay? So what does that equal to? Well, what expression times itself is 16x to the 4th? Well, 16 is easy. That's 4 times 4. What about x to the 4th? X squared, right? So x squared times x squared is x to the 4th. So whatever you put in here, it needs to be here, because that's what we mean by taking the square root of a radicand. So to find out what that equals, whatever that equals, it means that times itself will be the radicand, 16x to the 4th. Okay, so the answer is 4x squared. Kind of makes sense because 4 times 4 is 16. X squared times x squared is x to the 4th. All right. Now, you're not always going to deal with square roots. Let's say you had a cube root. Same idea, right? So if I had the cube root of 8, let's do y cubed. Let's do an easy one first. So the cube root of 8y cubed equals what? Well, what expression times itself 3 times, because cube root, 3 times is 8y cubed. Well, let's talk about the 8. What times itself 3 times is 8? 2 times 2 times 2. So 2 goes here. What times itself 3 times is y cubed? Well, just y. y, 2y, 2y, just like that. So the answer is 2y. So 2y times 2y times 2y is the radicand, 8y cubed. But then if I go a little bit further, if I ask myself, well, what is the cube root of 8y to the 12th? 8y to the 12th. Now, again, that's where you're going to have to use some ideas from a previous course. So you got to think about, well, what times itself 3 times is the radicand, 8y to the 12th? Well, the coefficients are always the easiest to deal with. What's the cube root of 8? Well, the cube root of 8 is 2, right? So 2, 2, 2. And then what I got to think about is this, is what expression times itself 3 times is y to the 12th? All right, so you got to think about it. You may say, well, what about y cubed? Well, let's think about it. What's y cubed times y cubed times y cubed? Well, that's y to the 9th, so that's not going to work. What about y to the 4th? Well, y to the 4th times y to the 4th times y to the 4th. You remember when you multiply like bases, you add exponents. 4 plus 4 plus 4 is 12. Oops. And so that's your answer. So we're going to get 2y to the 4th. See what I'm doing? And so that goes here, 2y to the 4th. Okay? So 2y to the 4th times itself 3 times will be 8y to the 12th, will be the radicand. Number 6, suppose we had the cube root of, let's say, 27, cube root 27, x to the 6th power, y to the 9th. So the cube root of 27, x to the 6th power, y to the 9th. All right, so remember you're asking yourself, what's the cube root of 27? That's always easiest to deal with. So what times itself 3 times is 27? Well, 3, right? That will give me 27. All right, let's talk about x to the 6th. So I know I'm going to have some x's in here, correct? So x to what power times x to that same power times x to that same power is x to the 6th. Well, x squared, right? Always think about it. X squared times x squared times x squared. When you multiply like bases, you add exponents. 2 plus 2 plus 2 is 6. So x squared. Now what about y to the 9th? How can I get y to the 9th? Well, y cubed times y cubed times y cubed, right? Because when you multiply like bases, you add exponents. 3 plus 3 plus 3 is 9. So that's 3x squared y cubed, 3x squared y cubed, 3x squared y cubed. So that's your answer. 3x squared y cubed. Okay? So that's number 6. Let's look at number 7. So number 7, we have, let's do another square root. So number 7. So number 7, we have the square root of x to the 12th divided by 25. All right, no big deal. We had that in a previous lesson. We took the square root of a fraction, and so basically you wrote this as the square root of x to the 12th divided by the square root of 25, right? And so the denominator is easy. What's the square root of 25? Well, that's just 5 because 5 times 5 is 25. But let's go to the square root of x to the 12th. Let's look at that for a moment. You just go off to the side sometimes, and it does help if you think about it on the side. So the square root of x to the 12th. So what times itself twice is x to the 12th? Because it's square root, right? So what times itself twice is x to the 12th? Well, let's try. You may say, well, what about x to the 4th? Not quite, because when I multiply x to the 4th times itself, that's x to the 8th. So that did not work. All right, what about x to the 6th? X to the 6th times x to the 6th is what? X to the 12th. So there you go, x to the 6th. So x to the 6th times itself is x to the 12th. So the answer is x to the 6th power. So x to the 6th times itself will give you a radicand, x to the 12th. Okay? So that goes in the numerator. So there's your answer. So the answer is x to the 6th divided by 5. Okay? Number 8, let's suppose we had the square root of, and this time we're going to, remember at the beginning of the lesson, we said our goal was to simplify something like this. Let's go ahead and do this now. I think you can do this. So we have the square root of 4a to the 22nd power times b to the 12th. Okay? So let's do the square root of 4 first. What do you think that is? Square root of 4. Well, that's 2, right? Because 2 times 2 is 4. Now let's look at a to the 22nd. Okay? So I'm looking at the square root of a to the 22nd. So think of it like that, square root of a to the 22nd. So the square root of a to the 22nd is going to equal some expression. And that expression will be, when you multiply by itself, you get a to the 22nd. So what do you think it is? So a to what power times a to what power is the 22nd. And guys, all you do is just take this exponent, divide by 2. So what's 22 divided by 2? 11. So the answer is 11. Same thing here. Look, what's 12 divided by 2? 6. So Exodus 6 times Exodus 6 is Exodus 12, right? Over here, let's go to number to number 6. So you see where I wanted three expressions to multiply together and give me Exodus 6. Well, what's 6 divided? Now remember, this time it's 3 cube root. So what's 6 divided by 3? 6 divided by 3 is 2. X squared times X squared times X squared. 9 divided by 3 is 3. Y cubed, Y cubed, Y cubed. See that? Same thing here. So remember, this was cube root. So I have y to the 12th. So what's 12 divided by 3? Well, 12 divided by 3 is 4. So y to the 4th, y to the 4th, y to the 4th. Okay? So that's all you really need to do is just for these in this lesson, just think about it like that. But remember, what this really means is this right here. So what times itself twice is a to the 22nd power. Well, I can easily find that exponent by just dividing this by 2, dividing this exponent by 2, by that index. See, there's no number there. Remember, that's square root, so there's no number there. That's understood to be 2. Okay, so I get 2a to the 11th power. Now, what about b to the 12th? So the square root of b to the 12th equals what? Well, my exponent is 12. I'm taking square root. So what times itself twice is b to the 12th? Well, all you do is just divide this by 2, and that will give you what your expression is. So 12 divided by 2 is 6, so I know I'm going to say b to the 6 times b to the 6. And it makes sense because when you multiply like bases, you add exponents, so 6 plus 6 is 12. So this becomes b to the 6th power. Okay? So the answer is 2a to the 11th, b to the 6th. That's what that is. Okay? Number 9. What about if you had the square root of 441 x to the 4th, y to the 2nd power, divided by 361 z to the, let's say, the 10th power. 10th power. Okay, so we have this. Okay, so let's talk about the square root of 441 first. Use your calculator. I mean, I don't expect you to know, like we did here, that the square root of 4 is 2 right away. Use your calculator. So in your calculator, you use your square root button. So remember how to get to it. So the square root, second x squared, square root of 441 is 21. So 21 goes here. And let's talk about the square root of x to the 4th. Let's think about that, square root of x to the 4th. So what times itself twice is x to the 4th? What do you think? Remember, the exponent is 4. You want that exponent to be 4, so add these two together to get that 4. So that means 2 plus 2 is 4. So that's x squared. Okay? Because remember, whatever you put here, you need to put here. So those have to be the same thing. So this is 21x squared. And then let's talk about the square root of y squared. So what do you think that equals? The square root of y squared. So what times itself twice is y squared? Well, y times y. Kind of makes sense because 2 divided by 2 is 1, so y to the 1st, y to the 1st. And so that goes here. So the numerator, so the square root of 441 x to the 4th, y to the 2nd power is 21 x squared y. Now the denominator, let's look at the square root of 361. So if we look at the square root of 361, use your calculator. The square root of 361, keep getting answer. Okay, let me do this again. Second square root, okay, 361 equal, I get 19. Okay, now let's go about z to the 10th. What do you think is the square root of z to the 10th? What do you think? Real quickly, most of you should be able to tell me right away. Okay, so think about this. What times itself twice is z to the 10th? So z to what power times z to what power is z to the 10th? So I need that to be 5, right? Because 5 plus 5 is 10. All right, so that's z to the 5th. So the denominator is going to be 19. The square root of 361 is 19. And the square root of z to the 10th is z to the 5th power. And so there's your answer. That's the answer. Okay. Number 10. So number 10, we have this idea. We have the square root of x minus 3 squared. What do you think that equals? What do you think? The square root of x minus 3 squared. Okay, you probably stuck, right? Well, let's think about what we talked about earlier. You remember earlier we said if I had the square root of some x raised to the second power, then again we're assuming that all variables are not going to be negative, so we don't need absolute value bars. So when I take the square root of some base raised to the second power, it's just your base, right? It's just x. Okay. So notice how I said this. The square root think of the radicand as this, a base squared. So my radicand is a base squared. And so the answer is just the base. And so if I look at this, I have the square root of a base. The base in this case is a binomial, x minus 3, but it's being squared, right? So that's going to be just x minus 3. And I don't need absolute value bars because we're assuming that all these variables are never going to be negative. Okay? All right, so that was number 10. Let's look at number 11. Number 11, let's suppose we had this, the square root of a squared minus 8a plus 16. All right. Now, don't let that throw you off. Most students can handle up to number 9. They really can. Because that's the easy kind. In this lesson, these are the easy kind. See how nice everything looked? Now, when you get to this point, and those are all monomials in the radicand. See the radicand? A monomial times a monomial times a monomial. Here, though, those are not monomials right here. That's a binomial. Here, that's a trinomial. But what you want to do is see if you can factor this trinomial. All right, factor this trinomial. And so, and I can, because when I factor this, I'm going to get the square root of a minus 4 squared. So this right here is a perfect square trinomial. And so when I factor this, I get a binomial squared, and now that looks like this. So I have the square root of some base squared. So when I have the square root of some base squared, it's just the base, right? So what's my base here? A minus 4. There's your answer. Okay? So the first thing you have to do is factor. Keep that in mind. So when you have a polynomial, see how this is already factored? When you have a polynomial, see if you can factor this. All right? Okay, number 12. Number 12, we have the square root of 8x cubed squared. The square root of 8x cubed squared. Don't make that difficult. Think about what that is. So I have, just like this, I have the square root of some base squared, right? And my base is 8x cubed. So what do you think the answer is? Yeah, 8x cubed. That's the answer. Just like we talked about here. The square root of some base squared is just the base. The square root of this base squared is just the base. After I factor this, the square root of this base squared is just the base. So the square root of this base squared is just the base. Now you may say, well, what happens if I multiply this out? The 8x cubed times itself. Okay, well, let's see what happens. What's 8 times 8? Okay, 64. What's x cubed times x cubed? X to the 6, right? Because when you multiply like bases, you add exponents. So this right here becomes the square root of 64x to the 6, right? But what's the square root of 64? Well, the square root of 64 is 8. That's what we had here. What is the square root? What is the square root of x to the 6? So in other words, what times itself twice is x to the 6? Well, x to the 3rd. And that's what we had here. So you can, if these are monomials and it's being squared, you can go ahead and multiply them out and then get the answer. But the point here was for you to remember that whenever you have the square root of some base squared, it's just a base. And that's what you have here. You have base here is 8x cubed and it's being squared. Okay? All right, number 13, let's do a couple more. Okay, number 13, you have, all right, 13, you have the square root of 11y squared. All right. Now again, make it simple in yourself. I have the square root of some base squared. What does that equal? The base. And you may say, all right, well, I know what 11y squared is. 11y times 11y is 121y squared, right? And so you may say, well, could I have done it this way, the square root of 121y squared, and then simplify that? Yeah, you can. But you also need to also know that when you have the square root of some base squared, it's just the base. And so you don't have to do this part, then come here and simplify this. So the square root of 121 is 11, and the square root of y squared is going to equal, remember what times itself is y squared, so you know it's just y, right? So that's just y. So you don't have to do that. Just knowing that what you see is the square root of some base squared, then you just get the base. And then finally, let's look at 14. At 14, we have the square root of 144 y squared minus 120y plus 25. So I'm taking the square root of this polynomial, right? And so what I want to do is try and factor this polynomial. So if I factor this polynomial, you should notice that this is a perfect square trinomial. So in other words, I'm able to write this as a binomial squared. In fact, 12y times 12y is 144y squared. And then notice the last sign is positive, right? So that middle sign has to be this sign here. And then for 25, I'm going to use 5 because 5 times 5 is 25. Okay? Now let's check and see if this is true right here. So 12y minus 5 times 12y minus 5. So I know that the first works out. That's 144y squared. I know that a negative 5 times negative 5 is 25. Look at the outer. The outer, you agree, is a negative 60y. And the inner, negative 5 times 12y is also a negative 60y. And we add them up, you get negative 120y, which is what you wanted. So this, when I factor the radicand, gives me this. So what's the answer? It is just the base. So the square root of some base squared is just the base. Okay? So this lesson was basically to introduce you how to simplify square roots and cube roots where my radicands were variables. Now notice the answers turn out to be nice, in this case, monomial factors. Same thing here, number 6. Those were nice. I mean, I could easily take the cube root of 27. I can take the cube root of x to the 6. I can take the cube root of y to the 9th. Okay? Same thing here. 7. The square root of this variable expression was just x squared y. So that wasn't difficult. Same thing here. And then it just turned out that when we got to this point where we had a polynomial, we have to remember that I'm thinking of this as the square root of some base squared. So I know it's just going to be that base. And so just think of it that way. Now, when you get to this point where you're taking the square root of a polynomial, like a trinomial, you need to try and factor it. And chances are you'll be able to factor it as a perfect square trinomial. Okay, so that is what I wanted to talk about in this lesson, where we talked about simplifying radicals containing variables. And remember, from this point forward, you don't have to worry about absolute value at all. Okay, so don't even worry about enclosing any of your answers in absolute value. Don't put absolute values anywhere. You're done. Okay, from this point forward, all of our variables are going to represent, when we talk about radical expressions, all of our variables are going to represent non-negative real numbers. Okay, so that's going to be the end of this lesson dealing with simplifying radicals containing variables.